This is a sample problem SS.C40, and SS stands for spanning sets. So we're going to start to look at spans. This is a span. A span is a set of vectors that we can then build a system of equations out of. So in this case, we're going to build a system of equations out of S by making these just linear operators on two variables. And W will be all the sets of solutions that happens when I do that. So I'll show you what that looks like in just a second. What we want to look at is a very specific vector x, 8, 5, negative 12, negative 5. And the question is, if I build all of the linear systems out of this that are possible, is this one of the solutions? And if so, we need to specify that. So let's take a look at what that means. So what does it mean that W is equal to the expanded S? Well, what it means is I'm going to take alpha times, or alpha 1, because we'll have two of them, times 2, negative 1, 3, 4. And then I'll add alpha 2. And these could be any variables. These are basically going to be just like our variables for our system. 3, 2, negative 2, 1. And this then forms a system of equations which has a solution. And our question is this one of them? 5, 8, negative 12, negative 5. If it is, then the answer to this question is yes. X would be an element of W, because W represents all the linear systems that this span can form. Again, a span is just a set of vectors, and if the set of vectors can, a linear system form of those vectors provides the solutions to a system, then we call it the span of that system or the span of that matrix. Okay, well, what does this mean? Well, this just means we've got a linear system with our variables alpha 1 and alpha 2. So what we need to do from this is build our augmented matrix. And of course, that's going to look like this. It'll be 2, 3, 5, negative 1, 2, 8, 3, negative 2, negative 12, and 4, 1, negative 5. And then we need this in reduced row echelon form. Now you might have noticed that your technology freaks out when you try this. It's because it's a system of 4 variable or 4 equations with only 2 variables. And it doesn't know what to do with the extra equations. Of course, we know what to do with that when we do our reduced row echelon form. But you'll find the technology kind of fails on this. Fortunately, it's an easy system to row reduce. And when you're done with it, this is what it looks like. I ended up having to do it manually because, like you'll find out, your technology does not like to row reduce any system of equations that has more equations than variables. Okay, and this is what I ended up with. 1, 0, negative 2, 0, 1, 3, 0, 0, 0, and 0, 0, 0. So you can see it produces a discrete solution. Alpha 1 is equal to negative 2, and alpha 2 is equal to 3. And what that means is, yes, X is an element of W because one of the systems this produces has this as its solutions if that system uses multipliers, negative 2 and 3. And we can kind of prove that right here if negative 2 times 2 is negative 4, and then 3 times 3 is 9, and 9 and negative 4 make 5. Negative 2 times negative 1 makes 2, and 3 times 2 makes 6, so 2 and 6 make 8. Negative 2 times 3 makes negative 6, and 3 times negative 2 makes negative 6, and negative 6 and negative 6 are negative 12, and 4 times negative 2 is negative 8, 3 times 1 is 3, negative 8, and 3 makes negative 5. So writing it out means negative 2 times this matrix, 2, negative 1, 3, 4, plus 3 times this matrix, 3, 2, negative 2, and 1, forms this matrix, 5, 8, negative 12, negative 5. So there it is. X really is an element of W.